Hello, my name is John William Lynch, and this is my CSC 480 Assignment 4 Part 1 code. To run my code, you simply just click play inside of this multinomial naive Bayes .java file, as long as the 5 other txt files are inside the exact same package that this one is in. I hard-coded my package name here for Assignment 4, but if you put all of these files into a different package, you can change this to say Assignment 2, like I have the above package, and it will work fine because it uses the source folder to determine where stuff is. So you can just click play, and it's a very basic output here. This was inspired by the discussion board post on D2L, and it gives me the overall word occurrences, and this is for our vocabulary, overall vocab, so that we can divide it by our overall current word later. Excuse me. And now if we go to the very bottom, it gives us the amount that we guessed correctly. So we guessed correctly 190 times, and we guessed incorrectly 10 times. So our calculator is pretty solid. And if we see the overall accuracy is 0.954, so 95%, which is pretty good. And now I have a very small user input interface here, and I believe Rex is one of the terms. So for vocab term Rex, it should belong to class hockey, and it gives you the probability of that as well for belonging to it. And now if you type in gibberish for error checking, it has one there, and then you can just enter in the value again. And then when you're done, you can click end, and it will exit you out. And this is all within a while loop. And now I just wanted to show my actual code here. So I apologize for the amount of hash maps I have and for the rather long names they have, but sometimes I would confuse my hash maps together because I had so many going. So I wanted to make sure that I commented enough with the proper names for each of them. The majority of my code, around half of it, is just for reading in the items into the file and assigning them to the 0 and 1s here. My comments do a much better job explaining it than I could in the 5 minutes, but essentially they add into certain values. For this one, we get the current document class, and we get it, and we add in which one it belongs to. I wanted to show my Laplace smoothing that I do inside of my probability testing, which occurs here. So this is when I'd run my training data set onto the probability. So I make 2 hash maps here, and these 2 hash maps taking a string, which is a term vocab name, and a double, which is the probability that they will have, which is usually a very small, large, with lots of decimals. And then I also have a hash map that says class for term, and that pretty much says that for term Rex or for term David, it belongs to class Microsoft or Hockey, represented by 0 or 1 respectively. I go through every 5,500 vocab terms row by row. I get the current term by using the current row index. These values here were belong to class Microsoft. I get current vocab term. Essentially just says get the vocab count for Microsoft for this word, the overall word, and then add a 1 to it. So this is my Laplace smoothing. Do the same for hockey. After I get those, I divide that vocab count I just got by the overall occurrences of the value. And that gives me my chance for Microsoft. And then I do the same for hockey, and then it's a very basic if and else statement that occurs here. Essentially, if Microsoft is greater than hockey, it should belong to Microsoft. So I put in to Microsoft the probability, the vocab term that we have, and then also the amount that it would belong to. For some reason, when I don't put these in, this line here, it would my code would have less predictions correct, and it might just be because it was missing a value, or this would be 0. And I also put in here for term vocab or something, I get a 0. So now if I go to my testing data, this is reading it in. I create my current test value. I get the overall amount of wrong and right guesses. And then I iterate by column. So essentially what we want to do is, like, for column 0, go through every row and then determine based on those vocab words which one it is. I make 2 dummy variables for holding values. I get a prepare guess, and then I read in the actual value associated with that document, which I found earlier. So I go through every row, part of a column. I get the ijth value of the current value in my test matrix. My vocab term is gotten from the vocab and documents get value I. And then if my current value is not equal to 0, so that we skip over vocab terms that are 0 and won't have anything, I add on to my probability for Microsoft what I found earlier in the code I showed displayed earlier. So this gives me a very small decimal, but I add them all together because we're going through every row in a single column. And again, very basic if-else statements. If one is larger than the other, do that one. And then if this one's larger than that one, do that one. And then, of course, I increment my correct and wrong guesses based on if it was correct or wrong, and I increment my test number. Before going 5 minutes, I just wanted to double check with the hard coding of anything. I wasn't sure if my hard coding of the, excuse me, if my hard coding of the values here was necessary. I was trying to figure out a way to read in the strings, or excuse me, the txt files properly without using it, but I wasn't able to figure that out properly. So that is my overall naive Bayes calculator, and thank you.